Example 1, factor x squared plus 7x plus 10, and we're actually given part of our answer. We're told this is equal to x plus 2 quantity times some other quantity. Well, we know from multiplying polynomials that the first two terms here, x times something, must be x squared. So that means this is going to be equal to x. And we also know that these two values on the end need to multiply. So 2 times something need to multiply to be 10. So that must be positive 5. So this factors as x plus 2 times x plus 5. Example 2. Factor x squared minus 11x plus 30 equals quantity x minus 5 times some unknown quantity. Well, again, we know the first term of our second factor must be x, because x times x would be x squared. And we also know the two numbers, negative 5 times something, need to equal 30. So that would mean this must be minus 6. Now, you can also notice that if you were to multiply these out completely, in the first example, 5 plus 2 would be 7. Negative 5 plus negative 6 would be negative 11. That also must be true. This is where our rules are going to come from in a minute. Example 3. Factor x squared minus 2x minus 99. We're told we have x plus 9 as a factor. Again, we know that the first term of our second factor must be x, because x times x would be x squared. But 9 times something must be equal to negative 99, so that must be minus 11. And again, 9 and negative 11 add to be negative 2. I'm going to use that reasoning to factor these next three. Example 4. Factor 25 minus 10x plus x squared. Well, the first thing I'm going to do is rewrite that into standard form, so that is x squared minus 10x plus 25. Now this is going to be a set of two binomial terms, the product of two binomial terms. And I know that my first terms need to be x, because x times x would be x squared. But what I now need to look for, I need to find numbers that multiply to be 25, my last number, but add to be my middle term, negative 10. Well, running down that list, it's not too long, I find that minus 5 and minus 5. So this factor is x minus 5 multiplied by x minus 5. Example 5, the numbers are a little bit bigger, but we have factor x squared minus 19x plus 84. So by the same logic, this one's already in standard form, but by the same logic, I'm going to have two binomial terms, and these two numbers that I'm going to place in here with my x's are going to multiply to be 84, but add to be negative 19. Now if you think about that for a moment, that means that these both need to be x minus something and x minus something else. So let's run down the list of factors of 84. 1 and 84, 2 and 42, 3 does not divide into that. Well, let's make sure of that. 84 divided by 3 is 28, so actually 3 and 28. 4 and 21, 5 does not. 6 and 14. Now, I may not need all of these, but can't hurt. 7 and 12. Let's see, 84 and 8. No, that doesn't work. 84 divided by 9. No. 84 divided by 10. 84 divided by 11. No. And then I get to 12, and that would be 7. Okay, so I have all my factors there. So I need to find two factors on this list that multiply to be 84. Well, they all multiply to be 84. I need numbers that add to be negative 19. Well, if you notice, these two, that's 85. 2 and 42 would be 44. 3 and 28 would be 31. 4 and 21 would be 25. 6 and 14 would add to be 20. And 7 and 12 would be 19. But I want negative 19, so I'm going to change these factors to be negative 7 and negative 12. So in my sets of parentheses, I'm going to have x minus 7, and in my second set, x minus 12. Now, one thing that I need to make note of is that this process only works if it is a 1x squared. Okay? If the a value in this polynomial is equal to 1. We have a separate type of thing we'll do for ones where that's not the case. All right, example 6. Factor x squared minus 10x plus 21. Again, this will be two binomial factors. Now, I need numbers that will multiply to be 21, but will add to be negative 10. So let's make a list of factors. I have 1 and 21. I have 2 and, no, make that 3 and 7. That's actually all I have. 1 and 21 add to be 22. 3 and 7 add to be 10. I need a negative 10, so this is going to be negative 3 and negative 7. Which makes my two binomial factors x minus 3 and x minus 7.